All right, that's 115 this morning. I'm going to try to get this set up and work through some introduction stuff to the equations out of this chapter and also fraction exponents that we're getting into starting this week. So get this set up and hope you join us. So adding and subtracting rational exponents is part of this chapter that I hope you've gotten started on. We're going to work from there into the other topics there. I'm going to do some addition and subtraction problems. That is, if you remember with fractions and when you're dealing with regular numbers, the fractions, adding and subtracting is the hardest thing to do with them because you need that common denominator. That is maybe slightly easier with rational expressions, but there's still quite a bit of work to that. So we're going to try out some of those. Equations actually is easier because there's more. There's another tool at our disposal that helps a lot with equations. So we're going to work through some of those. That is actually easier to do. And then fraction exponents, we're going to get the idea of what those are and how to write them in a couple of different forms. And that's leading into what we'll be doing, simplifying next week, the next kind of expressions we got to deal with. All right. So adding and subtracting problems, you need to get the exponent. You need to get the denominator to be the same in order to add them. So if you have an addition problem and they already have the same denominator, then you're in good shape for that. I'm trying to get some light on this paper still. This should help. So they do kind of separate these things out in the thinking here. You have things that are called like fractions, and that just means that the denominator already matches. You have a common denominator to start with. That's the easy kind of thing here. We're going to learn how to do those, and then we're going to learn how to turn the others into those because those are easy, right? So if you don't have common denominators, we're going to learn how to make them the same. But if they are the same, that's an easier problem to work through. So grab an example on this. I'm going to take some out of the book, I think. So I had that chapter ready to go here. There it is. These are kind of separated out in the exercises in the book in their own category, but they're easy to recognize because the denominators already match. Still a little work to do here. So I'm going to look at, it's actually number 82 from this chapter 7 in the book, and it looks like 7x squared over x squared minus 9 plus 21x over x squared minus 9. So when you look at that, you make the observation this is an addition problem with rational expressions. We have to add them, so we need a common denominator. And the second thing you should notice is that we already have a common denominator, so we're ready to go ahead and do addition. When you're dealing with fractions and the denominators are the same, that means you can add them up and just keep the denominator the same. This is going to go ahead and add up, and that'll be still over x squared minus 9. So the short version of answering this is I go ahead and add the numerators. This is addition. I got 7x squared plus 21x and keep the denominator the same. That common denominator just stays there. That is still bottom. And that's sort of it, except that we always want to write our answers in simplest form. So I still have to think about factors at this point and think about whether this thing factors or not. Now, if the first thing you thought when you saw x squared minus 9 was that that's a difference of squares, you can factor it into x minus 3 and x plus 3. That's good if that's the first thing that came to mind, because that's usually what we want to look at. We want to see if there's any common factors here. So we want to think about factored form on these things anyway. I'm just going to write that out in factored form now. And sure enough, something's going to simplify on this one, because that's why we picked this out as a nice example. That's difference of squares. Factoring the top one here is just a GCF. Looking at that thing and seeing, well, there's a 7x that goes into both of those. And if I factor out the 7x, that leaves an x. And that leaves a plus 3. So that's the only way to know whether I have common factors or not, is to think about them in factored form, or better yet, write them down in factored form, and then you can see easily that some of that's going to cancel. So there we go. A simplified form of that answer is just 7x over x minus 3. So adding and subtracting with rational expressions is really just adding and subtracting polynomials. Whatever you have on top is where the adding and subtracting happens. That might involve some combining like terms if you had like terms, that sort of thing. It's just an adding and subtracting polynomials problem, and then a simplify problem, which involves the factoring there. So it's sort of a combination of stuff we've already done. We just got to put it together and learn how that goes. And if the denominators don't match, we're going to make them match by multiplying top and bottom by something to make the denominators match up. We'll get to some of those. And there's quite a bit to cover here, so I'm going to start with one that has different denominators and think about what we need to think about there. Second example I want to do is just something that has completely different denominators in it. And then we're not going to be able to make things terribly complicated. I'm trying to just get the basic ideas of this section because that's what we need. And so we have time for still. So trying to thin this out. But I'm going to start with exercise where the denominators start off completely different. This is number 114 out of the textbook. And I'm using those because they're already doctored, so they probably simplify kind of nice. I just pick one out that I like. So that's the one I want to look at. Number 114 says add and subtract rational expressions with unlike denominators. So that's what it starts off looking like. And I have to recognize, first of all, I need a common denominator, and then that these are just two different things. They have a z in them, but I really should think of them this way with the containers. Those are two different factors right there. Z minus 2, z plus 5 are just two different factors, nothing in common. So if they're completely different here, then my common denominator is going to have to include both of those factors. The only thing I can turn both of these into to make them like fractions is I'm going to have the same thing here, but it's going to have to contain both of those factors. So really this has to become z minus 2 and z plus 5. Both of these have to become z minus 2 and z plus 5. And then I'll be able to add them. But I'm writing it down in both of them right now. And this step I want you to think about here, because I don't know what goes on top until I think this through. If I write that common denominator down separately, then I can look back and say, how do I turn this into that? What am I missing here that has to be there here? And it's obviously the z plus 5 factor. That's the new one. So if I have it written separately, I can identify the sort of missing factor. And that's the key step to those. If I recognize to turn this into a fraction that has this denominator, I'm missing the z plus 5. So that's what I have to multiply by. So I'm going back up here and thinking both of these have to be multiplied by a missing factor. I'm going to write it next to both of those, because multiplying by something, usually what I mean is just write it next to the thing and then think about multiplying it. There it is. The bottom matches up now. The top is 3z times z plus 5. So then I'm going to actually do out that multiplication. For this one, it had the z plus 5. It was missing the z minus 2. So that's the one that goes up here. I just point out we're at one of those places in this course where you have to kind of go back and forth between the step we're working on and the step that we came from, and think back and forth through this in order to get to the right place. So I can't just write down the next thing and go from there. I don't know what I'm doing here until I think about what this GCF is and compare and find the missing factors to put up here. So I'm really working back and forth between these steps, and that's why it's one of the more complicated things that we do. Now 1 times z minus 2 is z minus 2. And the bottom is already, those are already here. So that's what I have to put together on it. Now I have an addition problem with like denominators. So we do that like we did before. Keep the denominator and add together the things that are in the numerators. So I'll shift that up a little bit. Now it's going to become one fraction. My goal in all of these, our goal that we're going for in these rational expression problems, is to get a single fraction, and then I'll get it in simplest form. We got a single fraction now. Oh, I got to fill in the top. This is where the actual adding takes place. I add these things up. 3z squared plus 15z plus another 1z out here. These are the like terms, so I'm going to put those together. There's 16 of those. And then the negative 2, watch the signs on that. But you're just combining like terms at that point, adding the polynomials. Now I got a single fraction. I got to see if it's in simplest form. The denominator, notice I didn't multiply those out because I have to think about separate factors. I want to leave that in factored form. Now I want to write the numerator in factored form also to see if I can cancel anything. So that's where I'm putting. This is going to stay the same. I want to see if there's factors to this thing up there. There's no GCF this time between all of those terms. So this is a regular 3-term factoring problem. I'm going to think that through, see if I can come up with any common factors or any factors that I can cancel. So off to the side, I'm going through my factoring process. That multiplies to -6. I need numbers for my z term that add up to 16 and multiply to -6. But that's not going to happen here, right? There's not very many ways to multiply to -6. Not very many ways at all. None of those are going to add up to 16. So none of these work. So this is prime. So it doesn't simplify at all. I'm not going to be able to write it in factored form. So nothing is going to simplify here. This is just going to stay where it is. That is the simplest form. You have to check that. Any of the answers to these things you want to check for common factors, see if it can be simplified. That's it. So adding and subtracting all happens at this stage. Once you've made the denominators the same, you're just doing adding and subtracting with whatever terms you've got in the numerator now. Watching your like terms and stuff there. That's where the adding and subtracting actually happens. The simplifying is just after you do that adding and subtracting, you don't know if the thing's going to have factors or not. You got to check and see. That's the deal with those. And that is what happens when the denominators are completely different. Now I want to look at one where the denominators are not the same, but they have some stuff in common. I want to get one example of that. What if they're some things in common? So more like number 108. We're going back in the book to number 108. Let me get a fresh paper. Same process with these, except we got to think a little more about what that common denominator is going to be. This is a monomial example, so the factors are, there's not complicated factors in this one, there's just monomial things. Factors 12 and 9, and the factors are a bunch of A's and B's. I got different exponents on those. So what can I turn both of these things into? That's the question. I don't think this blue shows up to us. I'm going to go with a darker color. That's a cubed b squared, and this is a squared b cubed. What can I do that's going to contain all of the factors that are in there? And this is a common multiple question, or what? I'm going to have to multiply this by something to get this, and multiply this by something to get this. So what? This has to contain all the factors that are up there. So what do 12 and 9, this is my question next. What do the 12 and the 9 both go into? What contains 12 and 9 as factors? And that would be, the smallest number that works would be 36. The 36 contains both of those. I can turn 12 into 36 by multiplying. I can turn 9 into 36 by multiplying. So I'm going to have to think about what to multiply by, but I want to get it written down first. It's got to contain a cubed and a squared, and if I've got 3 of them, that's enough for both of those. So I'm going with a cubed. And b squared and b cubed, I'm going to go with b cubed because it has to contain a b cubed. And b cubed contains b squared. So this is the larger exponent on each of these. We're looking at a common multiple now. We're not looking at a common factor. So we go with the bigger exponent on those things. It's got to contain all of what I have up above. And then I can look at it and see what I'm missing now. So now I can compare back and forth. Once this is written down right, I have to be able to look at this and say, what do I multiply by to turn this into that? 9 times 4 is 36. The other missing factor is one of these A's. So I'm multiplying by 4A. Will come out to this. So the top, to keep the same value, the numerator has to be multiplied by 4A. So there's a difference here. If I had completely different denominators, then this would just be the thing that came from here because my common denominator would have to have both. But now I don't need that much here. I just need a little bit to make them the same. So you're finding, what do I need to multiply by to turn this into that contains all of this? 12, I need to multiply it by 3. Those match, and I need one more b on there. So this one is times 3b. That's what it's going to take to make this into that. So 1 times 3b is 3b. So I like to separate that out. I don't know what that thing is going to be until I can compare these two. So really getting the right thing written here as your common denominator is the key step to it all. Once you got that, you can go back and know what you need to do. Now the actual addition is easy. Now I've got like fractions. I just combine the like terms up here, but there aren't any like terms. 3b and 20a is all I have on top. Denominator stays the same. It doesn't go away here, but it stays the same. The denominator that I had is common. And then think about simplifying it here, but the top, in this case, doesn't factor at all. There's no common factor or anything that'll factor there. So that doesn't simplify at all. That's the final answer on those. So I don't want to get terribly complicated with these, but I want to get one where the factors are a little different, and I got to think through the factors a little bit more. So try to get one example of that done, and then we will spend a little time on equations, which honestly, the equation's much easier because we we got different tools when you get to equations. So it will, you get simpler after addition and subtraction. This is the hardest part of these. When they start off with different denominators, it's one of the more complicated processes. So I want to get another good example onto the video now, and you got some practice with this. Okay, that looks like a good example of it. Number 133 here. This is section 7.2 in the books where I'm taking these from. They're good examples of what's happening here. 3 over x squared minus 3x minus 4 minus 2. This one's a subtraction, but that's going to affect us when we're ready to actually do combining here. Not yet. These are different denominators. They both have an x squared. They both have a 4 there, although the sign is different. And that middle term is different. But thinking about terms doesn't help me at all here. I can't mess with the terms of these things to make them the same, because I can only... The one thing I can do with fractions that doesn't change the value of it is just multiplying. So I can only deal with factors. I can only deal with multiplying by factors. So the fact that they have terms that are kind of close doesn't matter to me. I have to think about the factors. So I'm going to write those in factored form. That's really the first step. We're used to that by now. Factoring everything is one of the first steps in this. I need the denominators in factored form. And these are pretty easy factoring things, so I'm just going to write this down without spending a ton of time on factoring, because these aren't hard ones to find. You get factors of x minus 1 and x minus 4 here, and x minus 4 and x plus 1 here. And then you can sit back and look at it. I should keep the denominators. I didn't change anything yet. I should keep that. Now I can sit and look and figure out what contains all of those factors. That's the key piece of the process here. What I write down here has to be the right common denominator. It has to contain all the factors that are up here. So look across the whole list. It has to contain an x minus 4. It has to contain an x plus 1. It has to contain an x minus 1. And it has to contain an x minus 4, but it already has an x minus 4. Right, I got that already. So those 3 should do it. That contains everything that's on the list here. And this one's got to be exactly the same. But I'm going to write it down again, because I got to be able to identify my missing factor. So write the LCD under there for both of them. And then I have to come up and answer this question, right? What am I multiplying by up here and up here to make them into that? And that's whatever you're missing. Comparison here, missing that one. That's what's got to go here. So that's what I multiply by on top. 3 times x minus 1. And then comparison here. They're out of order a little bit, but what I'm missing is the x plus 1 factor. That's what's got to go here. That's really the key to this, being able to write down the thing that contains all the factors and then identify what's missing. Now, if you get to here and you don't have everything that's up there, then you know you don't have the right common denominator written down. This should have all of those, but it should also have some stuff that wasn't up here, and that's what we're looking for, that missing factor. There's x plus 1 here. 2 times that is 2x plus 2. Now subtract. Now I'm ready to put them together and make a single fraction, because they're like denominators now. Denominator stays the same. Combine it. Do the combining alike terms up here. This is a subtraction now, so this is really 3x minus 2x is x, 1x. And be careful with this subtraction. It applies to all of this. It's the opposite of all of this. So this is negative 3 minus 2. It's negative 5, or x minus 5 is what I have on top. Think about simplifying now, but since this factor on top doesn't match any of the factors on the bottom, it doesn't simplify. So this is the final answer for that one. And that's what happens when you have denominators that are different to start with, but maybe they have some factors in common and some different factors. You can come up with a combination of factors that contains them all, and you need to get that common denominator. And you can get fairly complicated looking answers, right? We put that together and we got this great big long looking thing. And that might not seem terribly satisfying here, right? We're not solving anything. We're just getting this written as a single fraction and checking that it's in simplest form. And it doesn't really accomplish anything for us at this point, but that form is super useful if you want to understand what this function is doing. There's a lot that we can tell about it from here, but we're not going on to try to graph these things or do anything with these functions. So it's really just part of the puzzle here, getting it written in a particular form, and then you see this show up again much later on. It becomes a big deal in pre-calculus, being able to write them this way. We're not going any further with them, except we're going to solve equations with them, but not. The good news is we don't have to go through all this complicated stuff when we're dealing with an equation. I want to start with a comparison there and work through an old equation that we already know how to do, and then see how that applies to the equations we're trying to tackle now. So I want to remind you of something we did before with sort of regular equations. I'm skipping past these complex fractions in the book. There's a whole section on them in the book, and it involves adding and subtracting and multiplying and dividing, and we're just not going to tackle these more complicated things now. Not going to take the time. So I'm skipping to 7.6 in the book. Equations. Yeah, here we go. You know, we're going to do the simpler of these kinds of equations, and well, on we go from there. So I'm going to write this down, then I'm going to do a comparison to something we did before that hopefully looks familiar and helps you understand why we do what we do here. So something like number 208. Five over y minus 9 plus 1 over y plus 9 equals 18 over y squared minus 81. Now, this is solving an equation. This is actually trying to find the y value that makes this thing true. 5, 1, and 18. Well, but these fractions are supposed to come out to 18 over something. This is supposed to come out to the same value on both sides, and we're trying to find the y that makes it work. Now, y can't be 9, and it can't be negative 9, because that would make these things undefined. It'd be division by 0 problem. So there's a couple of things that are, we would say, not in the domain of these. There's a couple of off-limits numbers, but we're thinking there's probably some other number that if you plugged in the right thing, this would come out equal to that. That's what we're trying to find. But I want to make the comparison now, something we did before, so we can learn from that and make the connection here. We had fractions in equations before. They were just numerical fractions. So if I have something like 5/4 x plus 2 equals 1/3 x plus 8, that's just a regular linear equation because it's just x terms and number terms. So simpler, but we don't like dealing with fractions. Most complicated thing was fractions in this, so we would like to get rid of the fractions if we can. And we can because we can multiply by something to get rid of them. So if you did these the way that I recommended earlier on, you would look at this and think I got fourths and thirds, denominators of 4 and 3. So I can get rid of all that by doing 12 times 12, right? And by times 12, I meant write it next to everything. Right? We're going to do 12 times all of these things. And in doing that, we're going to be able to turn it into an equation that doesn't have fractions. So 12 divided by 4, 12 divided by 4 is just 3. I can take the 4 out and just leave a 3 there, so that's 15x. 12 times 2 doesn't simplify, that's just 24. 12 divided by 3 is just 4, so that's 4 times 1x. And 12 times 8 is just 96. I'm not going to go through solving that out from here. I just want to make the connection here. We can turn an equation with fractions into an equation without any fractions if we multiply by the right thing. I need something that's going to make all those denominators go away. Right? That's going to include all of the factors down here so that all of those are going to cancel out as common factors. And then I'll have an equation without fractions, which I solve. So I'm going to try to do the same thing over here. I want to figure out something that I can put up here next to each of these things that will make all of these denominators cancel. It includes all the factors of that. So I'm still trying to find a common multiple, a thing that contains all the factors that are in the denominator. First of all, I want to notice I need to factor this. Y minus 9 is a factor. Y plus 9 is a factor. And I want to write this in factored form also. So this thing turns into y minus 9 and y plus 9. I'm not going to rewrite the whole equation here. I'm just going to kind of replace that with its factored form. That's the way I want to write that to start with. Think about the factors that are there. If I want to contain all of these factors, it's got to be y minus 9 and y plus 9. And that does. That's enough to contain all the factors that are in there. Now, I'm not using it as a denominator. Now I'm using it as a multiple. That's what I have to put up here is those two factors. Y minus 9 and y plus 9 goes up here. I made my fractions, my parentheses a little too small here. I'll fit this in. Write it next to everything first. That is my common multiple. I'm using it as a multiple here because, just like over here, now I can get rid of all the denominators. In some ways, it's easier than over here because I don't have to think about multiplying and dividing. I just have to think about crossing stuff off. Right, this is gone. The y plus 9 is the same on the top and bottom. The y minus 9 is the same on top and bottom. And the y plus 9 is the same on the top and bottom. That seems like a lot of work to go through to just cross off a bunch of stuff. But look at what we got left. Not much. 5 in the y plus 9. And 1 in the y minus 9. And out of all this, just the 18 is all I got left. So we make it a lot longer to begin with by putting that common multiple on everything. But then a lot of stuff gets crossed off, including all the denominators. So I end up with an equation with no fractions in it now. Simpler to solve out from there. Let me get my camera actually off the over here. So now I can just solve this with normal algebra and not have to worry about fraction stuff. That's the goal of this. Solve it from there. I do have parentheses. I'm going to get rid of the parentheses. See what kind of equation I have then. Well, it ends up being just y terms and number terms. Just simple linear equation. Combine some stuff. I have like terms on the same side. 45 minus 9 is 36. Get the y term by itself. Well, I'm getting y by itself. So get that term. I'm going to subtract 36 from both sides. And then divide by the 6. I got y equals -3. Now, by then you've gotten lost in the symbols to the point where I don't remember what we were doing to start with. That's probably okay. We work our way through that. And then we're going to think back at this point. Does this work in the original? This is supposed to be an equation, solution to an equation. So I got to see if this thing works in the original. There's a couple of numbers I mentioned that y couldn't be because of the undefined expressions out here. I got restrictions on that, and I have to think about it. Y can't be 9 or -9. I mentioned that. But it turns out y is -3, and -3 should work just fine. So you do kind of have to check that, because sometimes what you end up with that looks like a solution is actually off limits here. But in this case, the -3 works okay. It's not going to cause a zero denominator. You can actually check it in the original if you want to do some calculations. This is 5 over -3 minus 9. And this is 1 over -3 plus 9. And it's supposed to come out to 18 over -3 squared minus 81, which is -72. Now, that's not real easy to check right there. You have some fractions there, but if you turn all those into something over 72, you get 30. -30 plus 12 is 18 over 72. Yeah. So it does actually check out in the original. Both coming out -18 over 72. So it works. It should work right there. It's just that you do sometimes get a number that's actually off limits. So you do have to go back and think about whether I'm going to get an undefined expression with it from some of these denominators, because that can get lost in the shuffle when you do this multiplying. So you have to be careful about that. But other than that, the solutions you get should actually work in the original equation. Let's think about that. Right, so we don't do anything terribly new on this. We're using this idea from before of how to take an equation with fractions and write it, or turn it into an equation without any fractions. And we do that by just multiplying by the right thing, multiplying every term by this common. It would be the common denominator of those, but we're not using it as a denominator. And that's what happens here. We look at the factors, figure out what would be the common denominator here, which is both of those. And we don't use it as a denominator. So I don't want any denominators. I'm using it, multiply both sides of the equation by that, and turn it into an equation without any fractions in it. The rest of that is old stuff that we can apply now because it's a regular equation. It might not come out as simple as this one does, but it's an equation without any denominators now. Right, it might be a polynomial thing where we have to use the zero factor property or something like that. But these are doctored so that they'll come out fairly nice at that point. But the new task here is how to take, how to find that common multiple and get rid of the fractional expressions. That'll make it into a polynomial equation again, which we'd have already done. Yeah, a lot of steps there, I understand. So that was one fairly long example on it. And looking back at it, that's kind of a mess that you end up with. The first step there gets so much going on because I'm not rewriting this thing a bunch of times. I'm trying to take care of it all by packing stuff into this first step. So I gotta there you go. I'll work through another example, but I got to leave some space and I got to think through those first couple of steps because that's really the key to that. So I'm going to do the live session on Friday afternoon also. I got more time there. I'm going to do the fraction exponents then. So I'm going to save that for Friday. I'm going to work another example on this equation stuff now. So that's really most of the work on this lab and homework is out of these equations. We're only starting to get into that other stuff. So I'll save that. I'll do one more equation with these different denominators here and work through that process one more time. So this is number 220. Looks like a good next example on this. Variables m this time. M over m plus 5 equals 50 over m squared minus 25 plus 6. Now this has a non-fraction piece to it. One of the terms doesn't have a denominator. That's okay. That happened with these kind of equations before. We would have some stuff that doesn't have a denominator, and we just multiply it out and get a bigger thing. So we're into a similar thing there. 6 isn't going to bother us much. We want to get rid of denominators on this. I'm going to write it out with some space because I know I need to multiply by a common multiple everywhere. And I also want to get all the denominators in factored form. I'm going to throw the containers around this because m plus 5 is a factor. That's good. This I can factor out. Easy factors there, but I want to write this out. So I'm going to write it out with some space. Now m over m plus 5 equals, or factored form of this is m minus plus 5. And I'm leaving some space and spreading this out because I know I need a common multiple to fit in there everywhere. So I just took the same equation, wrote it with the denominators in factored form and with some extra space around it so I can fit some stuff in. And now I got to think, what am I going to multiply by? What contains all of the factors that are in the denominators here? I don't care about the top, just looking at the denominators. I left my containers off that. But it's going to have to contain all of this stuff. That's m minus 5, m plus 5. That already contains the other one. This is trying to go fuzzy again. I'm going to try to get that readable. Wow. M minus 5 and m plus 5 are the only factors that show up in that denominator. So I'm going to multiply by m minus 5, m plus 5. That is my common multiple I'm using. So write it next to everything. This is one of these problems that a lot of students struggle with, and usually it's because they're trying to do 2 steps at once or move through things too quickly and not write stuff down, right? I just had a process there. They required me to write the exact same thing 3 times, and that seems tedious. It is a little bit tedious, but different stuff is going to cancel. If we don't have it written separately, it's hard to keep track of what cancels and what doesn't, and keep track of all of the pieces on this. So my suggestion is to write it out like this with a bunch of space. Think clearly about what is going to make all those denominators cancel, what contains all the factors in the denominators, and write it down next to everything. So it looks really long, now like a really great big long equation, but this is where it's going to get simpler now because get rid of the denominators now. So the m plus 5 cancels here. Both of those factors cancel here from the top and bottom, and nothing cancels over here because that's just 6 times a bunch of stuff. But that got a lot simpler. Let's write down what we got left. No denominators, but a bunch of terms up here. So let's see what it is. M times m minus 5 is m squared minus 5m. There's my equal sign. Just the 50 left on all this. That looks like a 56, but it's just a 50. That's a 0. That's all that's left of that one. And this, oh, this did get long right here. This is 6 times m minus 5 times m plus 5. And if you put those back to the non-factored form, the expanded form there, that's 6 times m squared minus 25. So I got 6m squared minus 150. That's where the actual multiplying got done with what didn't cancel. And it doesn't look great, but it has no fractions in it, right? We turned it into a polynomial equation. I can solve it now with normal polynomial stuff. It does have squared terms, so I'm going to try to solve this by the zero factor property. That's what we do with this kind of thing. Move everything to one side and get you 0, and write it in a nice descending order. So what am I doing? I have to get rid of m squared. Subtracting m squared from both sides is 5m squared. That would be my first term if I'm going to descending order. And then my m term is going to be a plus 5m on this side. It doesn't combine with anything there. That's just plus 5m. And then my numbers, 50 and a negative 150 adds up to a negative 100. Got the 0. Now I want to factor. 3-term factoring problem, but it's got a common factor, a GCF to pull out first. So a couple of steps in factoring, but I want to get the 5 out of the way because my GCF is 5. So factor out the 5. 100 divided by 5 is 20, negative 20 I have there. Still can factor this. Now this is 3-term factoring, but it has pretty simple factors. So still on factoring, I got m plus 5 and m minus 4 is my completely factored form. And then use the property. Property, zero factor property. This says either 5 equals 0, which it doesn't, or m plus 5 equals 0. So that would happen here if m was negative 5, or m minus 4 equals 0, which is going to happen if m is equal to 4. So those look like solutions to this thing. I say look like there, but I got to check this and see, make sure those actually work. One of them actually doesn't. So you have to stop now and think back to the original equation. It was numbers that were off limits up here. M could not be 5 or negative 5 because of these denominators. Those are numbers that are not in the domain here. 5 and negative 5 would be off limits. So that negative 5 that looks like a solution down here doesn't actually work. If you try to plug that in, you get undefined. On both sides of the equation, that doesn't really count as a solution. The 4 should be okay, though. The 4 should work out fine. And if you want to check it, you can. It's in the domain, so it should be fine there if you want to check that. But it's like 4 over 9 equals 50 over negative 9 plus 6. So there's a little work there in plugging it in, a little calculation work, but they do come out to the same number on that. So m equals 4 is the only solution we ended up with. That doesn't happen. That happens, but it doesn't actually work. This is the only number that'll actually work in that original equation. So the big step in these, we're running out of time, but the big step in these is being able to write the denominators in factored form and think about what this is. You got to be able to stare at those and write down what contains all of those factors. That it would be the common denominator of these fractions, but we're using it as a common multiple. Get that written everywhere, and we'll get rid of the denominators that way. A lot of pieces to keep track of. That's about as complicated as we want to get with those. Hopefully the ones in the lab are not any worse than that. But let me know if you get stuck on something in homework or on a lab as we go along. I'll be on for more time on Friday, and we'll do fraction exponents then, and probably some more of this stuff. But it's best if try stuff out and get stuck, and get me some questions between now and Friday. afternoon, and I'll work through any that you're unsure about then. So I'll talk to you all some more then. See ya.